Hello and welcome back to another episode of In Our Element. My name is Naomi Lewis and I'm a tech services engineer here at Materion. Today I will be very briefly discussing strain rate sensitivity. Stress strain curves are huge in understanding metallurgically how systems function and also how they fail. We know that strain is a material response to an applied stress, and we also know from previous videos perhaps that not all deformation is undesirable. Plastic deformation, like what we see in work hardening or strain hardening, functions to increase strength and decrease ductility by increasing dislocation density within the material. Things can get a little more confusing as we jump into the equations associated with strain rate sensitivity exponent and the strain hardening exponent, and that's because those equations look a lot alike, but they're not similar enough to be used interchangeably, so it's important to note the differences. The strain hardening exponent characterizes how stress changes with instantaneous strain, and that exponent is associated with true strain. This is contrary to the strain rate sensitivity exponent, which is associated with strain rate. If the material starts to convey different behaviors at varying strain rates, it has strain rate sensitivity. Strain rate sensitivity itself can tell us a couple different things based on just the sign. So why is any of that even important? Why do we care about strain, and why do we care about strain rate? Strain rate sensitivity shows us the tendency of a material to creep. Strain rate sensitivities closer to zero have a lower tendency to creep, and creep is the tendency for a material to permanently deform while undergoing persistent mechanical stresses. So not ideal for a design that you want to have around for years and years and years. Aside from creep, material strain behavior helps us understand how designs would react in situations like auto collisions. In a crash, the way energy is absorbed by the vehicle makes a huge difference in the safety of those inside. So that's all I have time for today, but be sure to check out our corresponding blog post for all the nitty-gritty details, and you can always reach out to tech services with any questions that you may have. Thanks, and we'll see you next time.